that's all Wendy.
Our fifth talk will actually have two presenters here. We have John Bell from Williams, as well as Tim Bond from Sardix. John is a geotechnical engineer for Williams with more than 15 years of industry-wide geotechnical engineering experience. He leads Williams' Landslide management program, which includes delineating, evaluating, remediating, and monitoring landslides on Williams pipeline rights-of-way in the northeastern United States. Mr. Bell's landslide management efforts have also led to his involvement with sophisticated LiDAR acquisition and review for landslide delineation and tracking purposes. Tim joins us and has nearly 28 years in photogrammetry, all with Sardix, in a variety of positions, including operations, cost estimating, project management, and business development. Tim is a certified photogrammetrist and a project management professional, focusing on remote sensing applications to the energy sector. Thank you, gentlemen.
Thank you. I'm going to stay away from the microphone. Hopefully I'm talking loud enough. Everybody hear me okay? Yes. Great. I'm going to roam around a little bit. We're going to, John and I will pass back and forth in terms of presentation. Just a quick overview of what we're going to step through today. We've already covered introductions. John's going to talk a little bit about his management program and his approach. We'll talk a little bit about the scope and how we contribute to that. So we fly aerial photography and LiDAR. I'll step through the process of how we acquired the data, the various components that went into that, and the quality control results that we realized, and then we'll get to the real meat of the presentation, which is John basically showing some of the examples that he's got, which is just fantastic. I'll just sit back and listen at that point. So I'll let John just briefly touch on his program.
Yeah, Williams has 1,500 miles of pipeline, mostly located in the northern panhandle of West Virginia, southeastern Ohio, a little bit in southwestern PA. It's high incidence landslide terrain, therefore you have to have a handle on landslides. So over the past decade, Williams has delineated 2,600 landslides on these pipeline right-of-ways. And the way to delineate these, you can't walk 1,500 miles of pipeline. Like, I'm in the landslide Sherpa, and like I get out there, but like it's too much. So what we found over the years, the best way to identify, evaluate, and monitor these landslides is to get LiDAR yearly, and then take this LiDAR, and then you can do like a full batch identification, and then you'll identify all new ones, monitor existing ones, evaluate them, reassess them, and what you're doing is you're figuring out which landslides to remediate, and in what order to remediate these landslides to protect not only pipeline integrity, but environmental integrity. So every year we get the LiDAR leaf off spring conditions. This year Sardix obtained our LiDAR, and I ingested all that LiDAR that Tim gave us, and Tim's gonna go over what he did to get this LiDAR, and then I'll go over what we did to monitor these landslides, and I'll give you 5 pretty decent examples from southeastern Ohio.
Awesome. It's always great to have a shirt on.
Self-proclaimed.
All right, so project challenges. I always like to look at this as like, hey, what's the risk? What's the challenge going in? Naturally, trying to acquire leaf-off, fixed-wing airborne LiDAR in a really, really short season has a lot of challenges that go with it. Primarily, we're waiting for the snow to melt, but we're trying to do that before the leaves pop out. It's like maybe an hour and a half window or something like that in this part of the country. So John's sort of targeted season is March 1 to 4/15. You know, in some years you might be a little early, some years you might be a bit late. And of course we're dealing with rugged terrain, heavy vegetation, a lot of challenges. In the terrain and the vegetation play into that because you're going to have a lot of snow on north slopes, a lot of places it's going to be tucked in. You're not exactly sure if it's melted and so forth. We had our ground surveyor out there a couple weeks before we were going to be ready to fly, and he took this ground photo for me on March 17th. You know, residual snow, but it was pretty prevalent. We saw a lot of it all over the place. So again, trying to time it as best we can, centered around the weather. John touched on his AOI. Those are the those are the two areas that they were focused on this particular year. So as I mentioned, our surveyor went out ahead of time, and we have sort of a two-phased approach. We're collecting over 50 what we call ground control points that we're going to use to control the LiDAR and make a slight adjustment vertically based on what the control tells us. And then we're going to have 50 independent QA points that we're going to use on the back end to analyze the final product. Those points are withheld from the production, so they're not influencing the math and the adjustment of the data, but it's a true independent assessment at the end. And you can see they're kind of hard to see on that graphic there. They're evenly distributed across the project. The control and the QA points are equally covering the project area. Just a couple of snapshots of the types of ground cover we're collecting on. So for a LiDAR-only project, those points do not have to be identifiable in the data because it's just LiDAR only. And we mix in hard surface points, and then on the QA side, we do a mixture of QA, hard surface points, and short grass to sort of get a feel for what the data is doing in those particular ground cover. So from a flight plan standpoint, there's a number of ways you could tackle it, right? You can actually plan flight lines centered over the route and make hundreds of turns back and forth to make sure you fully encompass the flight, the corridor that he's requesting. And they would like to have full tiles over those areas. So you have to fully cover not just the center line and not just the buffer, but you have to cover full tiles, which is not a problem. You just need to know that ahead of time. We took kind of a hybrid approach where we did big block coverage. As you can see over here, it's more efficient to just fly north-south lines, just like cutting the grass. Basically, you're going to traverse the lawn. And then we have these sort of offshoots here that are oriented diagonally to sort of have an efficient approach to covering the project area. Our aircraft flew about 5,300 feet above ground level, and we completed the project using our Optec Galaxy T2000 sensor. Yes?
Any reason for north-south instead of east-west?
It's always efficiency of flight plan. So if you have an area that's elongated north-south, you're going to cover that area much more efficiently with north-south lines than you would. So if it took maybe 15 lines going this way, it might take 30 or 40 lines to do it that way. And from an aerial operation standpoint, every time we're turning, we're not collecting data. That's wasted time, that's added cost, that type of thing. So we approach it in the most efficient manner as we can. So flight acquisition, we talked about the flight window and the challenges it comes from. We go one step further and we work south and north. If we get even a 5, 10, 15 day difference between conditions and vegetation on the southern side versus the north, that might make the difference between success and failure. So we go in with a heavy emphasis on working the southern side first. We were able to complete almost all of the project in less than 30 days. We started on April 2nd, and we were pretty much completed on April 28th. We did find one small reflight that I'll talk about here in a second. But again, working south to north, so I got a color-coded ramp there. And as we headed into what looked like the first weekend of acquisition, this is what the forecast was basically showing us. Basically, high chance of rain, storms on a daily basis. Oop, there's a small window coming this weekend. Let's make sure we were there and ready to acquire the data. This area down here is a small reflight that we found. I've got some examples on the turbulence that we experienced here in a second. One of the key ingredients to managing the acquisition of this program, both internally and sharing that status with John, was basically tracking what's been flown and what's not been flown, and working things in the most logical manner as we can. We use an internal flight tracking mechanism at Cerdex that has probably 15 different layers overlaid with this flight plan. It includes weather, it includes snow modeling, it includes other things like fires that we have to monitor out west and so forth. But one of the things that we do is we share this particular application with John. And this is visible on the desktop, it's visible on mobile, although it's a little bit clunky on a mobile phone. And it basically shows him where our aircraft are at any given time. It shows the progress as we're progressing. And probably most importantly, it shows what is remaining to be flown. Green means go fly. And blue is what's been acquired and in the process of quality control review. And so this tracker shows John and us on a daily basis. Is the crew up flying today or are they not flying today? It's not always a 100% given that that's going to be the case. And this tracker here is particularly useful because you can see here's today's progress, and then this one over here shows the progress in the last month. And we actually had 2 aircraft working the project. These screenshots were, looks like, I think it was April 20th. Oh yeah, on the trail here. And so you can see the one plane here and then another plane down south, and you can see their trail where they've been. So you can see their progress for a given day. And I don't know if John has any thoughts on the tracker, how useful that was, but just from a knowledge standpoint, knowing that planes are on site and they're acquiring.
Yeah, it was totally interesting to see, you know, one day you'd be like, oh no, there's not that much that was flown, and then all of a sudden it was like, boom, it was like half of one of the little chunks was flown. I was like, wow, they're really out there, so it was pretty cool to get updated.
Yeah. The previous slide had the date window, so you can see here from April 20th through the 28th, we had flights on 6 days in that window. In most cases, we had 2 aircraft flying. So I did mention we'd have one minor reflight for turbulence. That was another sort of gradient, like we needed another complicating factor in. We have to contend with turbulence, high excess winds, bouncing the aircraft all over the place. And occasionally that causes a roll gap where we have a very, very small area where there's no data collected. Even with the side left that we have, sometimes the sensor, the plane are moving around that much to where you get this small, minor little incident. And I think all told, all of those gaps were less than 400 acres. And they literally amounted to very, very small slivers of polygons. Obviously this is just an imagery shot, but it shows you just the small nature of those reflights. And in terms of product accuracy, I mentioned earlier we had 50 points that we withheld from production to do that sort of independent analysis. And we were very happy with results, an average of 3.5 centimeters, 3.75 centimeters, and an RMS of just under 5 centimeters as a whole. So again, really, really good residual and confidence in the quality of the data that we're passing on to John. He's going to be able to accurately use that to complete his part, and I will let him talk about his examples here.
So we don't care about how he gets the LiDAR, right? Wait, we do actually, but anyway, it's what I do with it. So Tim gets the LiDAR, he gives classified LAS files to our GIS team. Like I said, landslides and LiDAR, it's one of the best methods we have for delineating landslides over 1,500 miles of pipe. I can't walk them all, we can't fly them all, we're gonna miss a lot of stuff. There's vegetation everywhere, like the LiDAR gets through that vegetation pretty well. And the last example I'll show you is like one really good example of, wow, I'd have never known about this landslide if I didn't have LiDAR. So we'll go through some examples, but first I wanted to go over what we do with Tim's LiDAR to get some derivatives so I can pan through the entire pipeline system on my computer, delineate all new landslides, take a look at all existing landslides, and then reassess them to figure out which landslides I'm going to mitigate, what order to mitigate them in. Intensity, each LiDAR, you guys probably know this stuff better than I do, but this is how I understand it. Each LiDAR laser beam bounces off the ground, bounces off water, bounces off leaves, and returns a different intensity. You can develop like an aerial photograph from it. So you'll see on this image, You can see like right in the middle, there's like a scarp you're seeing, and it's like, I don't use the intensity image all that often, but it's really good to find seeps and other waterways, so it's something we started incorporating, I think like 2 or 3 years ago, but it's one of the cool ones I use, and I don't use it all that often, but I still do use it. Hill shading, this is one I we used in the past, and then I still use it, but I lean on slope more, but hill shading is, you tell the GIS computer or whatever to shine a hypothetical light source off the ground at a certain angle, and then abrupt transitions in elevation will be shattered. It's like, you know, the sun shining on the moon, you'll see the craters on the moon. And like those abrupt transitions in elevation, those are landslide features, scarps, toe bulges, stuff like that. Slope derivative, you tell the computer to highlight different slope grades, different colors, and then you'll start to see scars in the earth, downslope earth movement, like something like right in there. Like that's a landslide, you know? Same with the hill shade you're seeing. This is all the same image, by the way. Change detection. You have successive LiDAR data sets. You tell the computer to highlight areas blue that have decreased in elevation, areas yellow that have increased. Darker means more. So you can see there's that blob. Like that's the chunk that moved between 2022 and 2020. So I panned through the entire 1,500 miles of pipe. I look through all 4 of these, and then I'll figure out where the landslides are, and I'll look at the existing landslides to see if they started moving around, getting bigger, etc. So we'll go over, I got 5 pretty cool examples of landslides that we delineated in Southeast Ohio with the 2022 LiDAR, and let's start looking at them. Landslide 70063. You can see in the intensity image upper left, there's a scarp kind of visible there, and then if you see on the hillshade, that scarp kind of comes down along the right-of-way, across the right-of-way, and goes into the woods, and then you can really make it out on the slope derivative right here. That's the landslide blob right there. The change detection, there's a lot of noise in it because we use different vendors from 2020 to 2022, and there's like spatial adjustments and stuff. But you can still make out the change detection. Like that landslide moved enough, you're seeing the blue and yellow. It's that blob right there in the middle. So it's like, it still came in handy. If you use the same vendor, like that change detection gets even more and more powerful. Like, because they have the same survey control points that they're tying into. So that's something to think about. So I went out, I looked at this landslide. You can see here, that's a 3-foot scarp on the upper left-hand image. You can see the scarp kind of goes towards the woods, into the woods. And this is me looking, the bottom left photo, this is me looking on the other slope at that hill. You can see the pipeline marker that's right through that landslide. And then the right image, like that's me looking out of the woods, taking a picture of the scarp. So we repaired this one, I think 3 months ago. We dug the pipe up. It was like, we're trying to maintain pipeline integrity. And this one was kind of like sloughing down into the stream. So we cleaned everything up, and it's been a success so far. Landslide 70107. You can see the intensity image, you're starting to make out like potentially a scarp on the right of way, and you can kind of make it out on the hillshade. You look up there, and the scarp is right here, so it's in the same location on all 4 of them, but you can really see it on the slope derivative there. This is a scarp. Yeah, it's like you're starting to see like maybe there's some morphed out action happening in the woods. And then in the change detection, you're not seeing all that much. You just make out that scarp. So it's like something's happening out there. So we went out and looked at this site. I went out, this was like months after LiDAR, but you see it's pretty vegetated. You can see my pipeline marker, the yellow flag. It's going up the hill, so the scarp's like kind of right with the pipeline marker. You look up the hill, you start to see the scarp. It's kind of vegged over, but upper right image, that's me looking at the scarp. Go down to the lower left, that's the scarp right there. It dropped kind of like this much, pretty vegged up, so it's hard to make out. And then this is in the woods. Like I started walking that scarp back into the woods, and I was like, wow, this is like a morphed out landslide feature. Like it's an ancient landslide. So we put our pipe in, like kind of through an ancient landslide, and something happened. So this is one. Right now the pipe's like right along the edge of it, so I'm not totally worried about it, but I'm gonna have to keep an eye on this, because if this starts moving more, like I'm gonna have to go in and do something. So this is one, like, Next year's LiDAR, I get like, I'm gonna have to compare the two of them. Like, is this thing still moving? Like, the pipe seems to be okay, but if it starts moving over across, and it's like, this is stuff you have to look at every year to really get a handle on it.
How hard is it to get to that, any of these, like, are they?
This one wasn't bad. Some of them are like, they're extreme. Like, I used to not use a walking stick when I went out on hills. Now I use a walking stick, and I'm like, how did I ever do this without a stick? Like, it's like, not only am I a Sherpa, I'm a ninja. I'm like hopping these hills. It's really insane.
What's the depth of these slides though, John? Like, you showed him on the top of being 3 feet, but how far down do they go?
Well, sometimes we don't always know until we dig them up, but some of them are deep. Like, we put inclinometers in the ground on some of these, and like, they can get up to 10, 15 feet deep or plus. And when my pipe's at 5 feet, like, it's moving below. A lot of them are shallower, and sometimes it's tough to tell, but when the landslide moves, if you have a pipe through it, you pin flag it. Sometimes you'll see the pin flags like, oh, that pipe has moved, and then it's like you mobilize in and repair it. So it's tough to tell. You could drill test borings, but like some of these sites, like I can barely walk to them. Like, I don't know how I'm getting a test boring rig on there. There's like hand equipment you can use, but like that's still difficult. Landslide 70138. I don't have change detection. This must have been the first time we got LiDAR in this area. It was one of the newer pipes. So you see in the aerial image, I think that was from 2021. I think this pipe was installed in like 2020 or something like that. But you can see like someone went in and did something. You can see like there's a path coming down some disturbed area. And it's like, I don't know what exactly happened, but ops may have seen that something was happening, went in and repaired something. But sure enough, like 2 years later, it started moving again. You see in the intensity image, there's that scarp, the hillshade, slope. You can see it's starting to maybe move towards the stream, like trying to protect the stream too. Not so worried about this pipeline, but the stream is something I really have to consider. So this is one on our list for next year. But you can, this also illustrates, like, it's kind of important to look at all three of them. Like, the slope, obviously, you can really see it. And I know, like, if everyone else is doing this, they're normally using slope derivative, some kind of like combo between slope and hillshade. But I'll go through all three, and it's like, the reason why I keep doing the hillshades is I have stuff from 2016 where I don't have all the slope derivatives, but I do have the hillshades. So it's like, I can easily look through the hillshades and make out changes. And I go back and look through all the old stuff all the time. That gives me a good handle on, like, do I need to repair this slide or not? Like, if it hasn't moved in 5 years, like, I'll wait it out a little bit. Like, these things, it's not like it costs $20 to repair a landslide. They're expensive. Here's some pics of this one. That's the scarp. You can see it, like, it's not non-visible, but it's not something like, you know, you just walk and you're like, oh, it's giant landslide. Like, you gotta kind of be on the scarp. The bulge is down there, starting to kind of get towards the stream. You see the pipeline marker. I love it when I go to a site and they actually have the pipeline marker. That helps. Sometimes I'll go to a site, I'm like, oh, where's this pipe? And then I have to have ops actually go and stake it. And then they'll be like, oh, the pipe's okay. And I go out and look at it. I'm like, this pipe's bowed 2 feet through this landslide. Like, what were you looking at? So I always go out after they pin flag. I'll always go out and take a look at it. No matter what, even if the ops guy is like, yeah, it's totally fine. I'm like, I'm looking at it. I've seen that happen a bunch of times. 70164, this landslide in this area, you can kind of make out some cracking. That's a pipeline, the yellow line, by the way, if you guys hadn't figured that out. But you can see on the hillshade, there's lots of action happening there. The slope derivative, man, you can really see it. And this highlights, like, man, slope is really powerful stuff. And this one's pretty big. Change detection, like a lot of action is happening on this hillside. And if you go to the next page, I walked this one and I was like, I got to it and I was like, ah. It's like you get to some of them, you're like, that's so big. You can see the scarp. They pin flag this one. The pin flags do go through the scarp, but this pipe's pretty deep and it's like just at the top of the scarp. And my gut says like the movement's probably above it. But this is something I still want to keep my eye on. Like this pipe, and actually in this image, this pipe comes up the hill and the PI is like this. So it kind of like parallels the slide. So like if this thing keeps going up slope, like I'm gonna have to do something about it. And like this one's not gonna be cheap. It's easy to get to, but it's big. There's a lot of dirt we're gonna move around for this one. So I'll keep my eye on this and the 2023 LiDAR. I'll be pretty interested to see what that yields. And not only the LiDAR, like I have this on my list to go back out and look at like once a month, once every couple months. Like I have a list of stuff like I'm doing the field patrols in between if I need to. And aerial patrols, like we do those too. All right, so this is the last one I have, and this one's pretty cool because I would have never found this landslide, and walking on it, like, didn't even know it was there. And it's not a bad landslide, but like, now I have a baseline on this, so if this thing keeps moving, like, it's like, okay, I knew what it was like in 2022, and then you can kind of get a feel for what it is. But aerial image, you see nothing, intensity, little to nothing. The hill shape, the only way you can really make it out is this water bar is a break in it. So then you can see in the slope derivative too, like water bars are breaking it right there. So I went out and looked at this one because I was like, it's a little different. I didn't really expect this one to be there, and it was not the steepest slope. Like, yeah, it's a slope, but you can see here, this is me walking in. This is big hill. This is a big walk too. But I was walking down the hill, looked across, and like, don't really see much. Got up closer, don't really see much. This is me standing on that water bar break. Like, it's so vegged in, like, you don't see it. And then the one on the right, like, I was poking into it with my stick, and like, oh, okay, there is a break there, but like, you can't see anything. But like, the LiDAR caught it, and like, what I'll do is go back and look at this LiDAR, you know, and compare it to, 2023. If it moves 2 feet, like, geez, I gotta really start looking at this thing. If it stays like that, might not ever be a problem, so I'll just kind of leave it as it is. But, perfect. We got a few minutes for questions if anybody has any.
My first question is on the point density. You have mentioned you used 10 points per square meter. Considering the nature of the work and also the flight has been extended or it has gone up to end of April where the vegetation would have come, do you think this 10 points is adequate or not enough, or a better point density will be more useful? What are your thoughts on that?
Yeah, John might have some thoughts on that. I mean, I think 10 points per square meter gives you a really nice fidelity of data without getting to a point of diminishing returns. You could fly 100 points per square meter. You're looking for what, foot vertically for the most part?
Yeah, it was like 10 inches or something. I forget what it is in specs, but yeah, from my perspective, like the LiDAR was awesome. Like I didn't miss a beat this time. Some of the other ones, like I'll miss stuff. Like this is one of the best years I've had, so it's enough. I know he's probably throwing more energy off the ground than just 10, just in order to get the 10. But like,
Yeah, we held 10 as the minimum.
yeah,
So
10
we
is
had plenty
like
of places where we
got to get it everywhere.
15,
So, like, he's throwing
17,
50, whatever it is. That's
there were
standard
cases
throws.
where more. And we had cross lines overlap, so there were plenty of cases where we had 40, 50, 60 points per square meter, just drape it in.
Again, I don't really care what he does. I mean, I do because it affects me. But I care about what I'm getting. My GIS person cares about what he's giving them, and it's like, she just wants it in, and she's like, oh, everything's perfect, and gives it to me, and she's like, well, let me know how it is. And then I go through it, and I'm like, whoa, this is really good. And it's like, there's like a 3-tiered system, and it's like, it all kind of goes hand in hand. Yeah.
How long does it take you to go through all of this and find these on a yearly basis? The ones that you're like, hey, I gotta get out there and see what's going on.
Yeah, like 10 minutes. It takes like a month to go through the LiDAR, and then I'll spend months looking at him in the field. Then I have a punch list, and then I gotta go back out and do more and more and more. Like, it just never stops, and I'm doing other stuff in between. Not only do I do it for like these, identify landslides and operating pipelines, we're capturing LiDAR for proposed pipelines, and they're using it to permit the pipelines. Like, it's a survey. And then they'll come to me and go, hey, do a geohazard assessment. I'll do a geohazard assessment and go, hey, you're putting a pipe through like 8 landslides here. Like, you better think about it. And then I give them plans, and I'm like, this is what you probably need to do. And then when they go out and construct, they're like, you're crazy. And I go out and look at it, and I'm like, okay, maybe we don't need to put 9 drains in. But it's like I'm using it for proposed stuff too, not just existing.
Yeah, and I've been using aerial photography for 30 years, and this is to the next level. Like, this is really cutting through it all. And as John showed with the intensity, you're getting basically a low-res paint. anchromatic equivalent by the time we get the data to that.
Yeah, I didn't know about intensity until Angie, our GIS person, was like, hey, intensity, and I was like, whoa, this is pretty cool. Like, she introduces me to like the new stuff. Like, you guys are the GIS experts. Like, I'm the dude hopping the hillsides looking at landslides. Yeah.
Do you commonly capture any other imagery afterwards, during your reviews, like UAV or panoramic imagery or anything like that?
Yeah, we have a drone team that'll go out and get stuff, and we do the aerial patrols. I mean, they're kind of doing their own thing. Like, the LiDAR is so powerful, like, I don't need anything else for what I'm doing, but yeah, sometimes, like, we need stuff in between. Like, we had a pipeline that was exposed in a big creek, and we went out and we did multiple drone surveys on that over time, just because it was like, I'm only doing yearly LiDAR and stuff is happening in between. Yeah.
Do you ever find any other operators or consortiums that want to share the cost as you on the footprint, or is this kind of a waiting thing?
Yeah, we're looking into that. It gets tricky though, because the lawyers kind of interject in it and it's information sharing, but yeah, there's definitely, like, for instance, I went out to look at a landslide the other day, and I parked on top of a TC Energy, like right next to a TC Energy pipeline marker, and I was like, hey Clay, check this out. I took a picture and texted it to him. I'm like, I know where your pipe's at. Like, tell your lawyer that, right? It's like I'm walking right away, and I'm like, the Dominion's here, EQT, like, I'm walking, I see it, so. Yeah. So.
Do you ever correlate with any, like, ILI, bend, strain data, anything like that?
Williams does not, but the other guys do. Like, I'm part of these landslide management JIPs, and they do a ton of that stuff, and it's fascinating to me. And I'm like, oh, I wish Williams had all this. Like, but we have, like, ours is all gathering, so it's not regulated, at least not yet. So we don't have to do all the ILI runs. We just have to like pig it out and clean it out. But once we do all the ILI runs, like, that's going to be some pretty cool stuff. Like, it picks up different strain values, and it's kind of tough to correlate, but when you have like, an elevated strain value and a landslide, you're like, Yeah. So I don't know all that much about it, but I do know like some of the other operators they're light years ahead of me on that.
Does that run into your risk with NAOB?
It can, yeah. Big time.
One more question?
One more.
Do you have a programmatic way of identifying areas that need a second look, or is that just a manual review?
I go through, and then we have a 6-tiered system for pipeline integrity and environmental integrity, and it's 1 through 6. And if I look through on the computer and I give it a 3 or higher, I'll go out and look at it in the field. Then I readjust. A lot of times I go lower. Sometimes I'm like, whoa, and it goes higher. And then we remediate the highest numbers and work our way down.
I'm sure if there's any other follow-up questions, you can just talk with them during lunchtime.
Yeah.
Thank you, gentlemen.
Thank you.